Okay, getting started here. I'm gonna share out some info of the stream before we get going. Let's see here. It should be available somewhere, right? Let's see, youtube.com. Teams channel, we're live. And let's copy that and share in Discord, and then we'll get going. And going live with the TDD agent. Anyone wants to come hang out. And let's see, where else should we share it for now? I'm going to do a second stream of the TDD pairing with the TDD agent. Here we go. And oops, that's the wrong link. Let's see, what's the link here? Day one? Yeah, so it's day two, okay. That's right, okay. Shared that, and let's get going, I guess. Okay, so for day two, we've got, I was told there would be no math. The elves are running. The elves are running low on wrapping paper, so they need to submit an order for more. They have a list of the dimensions, length, width, and height for each present, and only want to order exactly as much as they need. Fortunately, every present is a box, a perfect right rectangular prism, which makes calculating the required wrapping paper for each gift a little easier. Find the surface area of the box, which is 2 times length times width plus 2 times width times height plus 2 times height times length. The elves also need a little extra paper for each present, the area of the smallest side. For example, a present with dimensions 2 by 3 by 4 requires 2 times 6 plus 2 times 12 plus 2 times 8 equals 52 square feet of wrapping paper plus 6 square feet of slack for a total of 58 square feet. The present with dimensions 1 by 1 by 10 requires blah 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 for a total of 43 feet. All numbers in the elves list are in feet. How many total square feet of wrapping paper should they order? Okay, so let's get set up here in the editor. We still have yesterday, or the day one's project, so let's go ahead and create a new folder for day two, and let's create, let's see, so what are we, let's say we've got presents. Let's switch back to the browser. So we've got, we're going to get a list of presents. Submit an order for more. A list of dimensions of each present. Only want to order as much as they need. Okay, so we're going to have presents that have dimensions, and we need to know how many square feet of wrapping paper we need. So it seems like a good start. So for, here we go, day two, we're going to have a new file of present.rb and new file of present spec.rb. And let's go ahead and move present.rb over here and close santa.rb from yesterday, or from day one, and we can require rspec and require relative dot slash present RB. And let's go ahead and set up the pair here. So testing agent pair on day 2 / present.rb and day 2 present spec.rb. Cool, and tests are passing. And we can get going. Okay, so let's say describe our spec agent present do and save. And so we've got our present class. And so we're going to have a couple methods here. One, we're going to initialize it with a dimension, looks like a dimension string, so 2 by 3 by 4. And so we also want to get, let's say, present is a box, the surface area of the box, and then we need a little extra paper, so the area of the smallest side. So let's say, right, okay, so we need dimensions, describe dimensions, and let's go ahead and, or actually we have dimensions, we want square feet. Present dimension requires, oh, we want the surface area of the box. Surface area, and we can say it is 52 when given 2 by 3 by 4, and it is 42 when given 1 by 1 by 10. And so if we do present equals present dot new 2 by 3 by 4, and then expect present dot surface area to equal 52, and present equals present 1 by 1 by 10, and expect present dot surface area to equal 42. Those are the tests we've got from the example, so we might as well throw these in. Looks like it's going to, tests are still failing, and looks like we might need to give it a little bit of help. Oh, the tests are passing. Cool, does it do it right? Oh, it actually gets the smallest side in the surface area. Sides.sum and sides.min. Why does it get the smallest side there? But okay. Well, let's do let's try to create that smallest side. Also need a little extra paper for each present. The area of the smallest side. Smallest side area. And it is 6 when given 2 by 3 by 4, and it is 1 when given 1 by 1 foot slack 1 by 1 by 10. The area of the small side, okay. Present equals present dot new 2 by 3 by 6, present new, 1 by 10, expect small side area to equal 1. Okay, so now the tests are failing again because the method doesn't exist. We've got the smallest side area, and tests failing, tests are passing. And looks like it got the smallest side area out of there. And let's go ahead and create this final method here of find the surface area of the box. And so this is wrapping paper. Square foot paper total. And let's say it is 58 when given 2 by 3 by 4, and it is 43 when given 1 by 1 by 10, and present equals present and new, expect present on wrapping paper to equal 58, and that, expect, and here we go. Tests are passing. Wrapping paper total. And tests are passing, and interestingly, it wanted to actually just call the wrapping paper method. So yeah, you can run with it. Tests are passing. I guess we can go ahead and get the puzzle input and new file input, and we can do our solution.rb. Require present. Typing is bad today, and this is going to be, let's see, we want over here. Let's see, it's presence, or let's say total square feet equals 0. Input and present equals present.new line, total square feet plus equals wrapping paper total, and let's put total square feet. And it seems like it should work. Let's see. Let's see, 2 and Ruby solution.rb. 1588178. Let's see. Over to the browser. Put the answer in. 1588178. That's the right answer. Cool. We got a gold star. Now on to part 2. The elves are also running low on ribbon. Ribbon is all the same width, so they only have to worry about the length they need to order, which they would again like to be exact. The ribbon required to wrap a present is the shortest distance around its sides or the smallest perimeter of any one face. Each present also requires a bow made out of ribbon as well. The feet of ribbon required for the bow is equal to the cubic feet of volume of the present. Don't ask how they tie the bow though, they'll never tell. For example, a present with dimensions of 2 by 3 by 4 requires 2 plus 2 plus 3 plus 3 feet of ribbon to wrap the present, plus 2 times 3 times 4 feet of ribbon for the bow. Total of 34 feet. Present with dimensions 1 by 1 by 10 requires 4 feet of ribbon to wrap the present for the bow, for a total of 14 feet. How many feet of ribbon should they order? So let's see here. Let's go back to the editor and to the present or present spec and back to the testing agent. And we need a couple more methods here. We are going to need, looks like this problem is a little bit in the training set, or in the training data. So we're able to cheat here a little bit. So maybe advent of code isn't a great problem to TDD with AI, but here we are. Let's keep going with it and see if we can get into a place where it doesn't know the answers. So we want to get ribbon length. We want to get the ribbon required the shortest distance around its side. Describe smallest perimeter. Perfect pose equal to cubic feet volume of the present. Describe cubic feet volume. Okay, so for the smallest perimeter, it is 10 when given 2 by 3 by 4, and it is 4 when given 1 by 1 by 10. And it is, well, let's go ahead and do this here. Present by dot new, expects present dot smallest perimeter equal 10. Present equals present dot new, expect present smallest perimeter equal 4. So now we are getting 2 failing tests, smallest perimeter, test passing. Let's go ahead and get cubic feet volume. It is 24 when given 2 by 3 by 4. Present dot new. It is 10 when given 1 by 1 by 10. Second, just want to make sure. Cool. Let's see. So given 1 by 10. Cool. And tests are failing. We've got cubic feet volume. Cool. And so ribbon length is 34 when given 2 by 3 by 4, and let's do this. Let's say if it's going to finish that, It is 14 when given 1 by 1 by 10. Present new, expect present length 14. Right. Okay, and tests are still passing because it's not actually using any of these, any of the helper methods we wrote, but it looks like it doesn't matter for now. Maybe as the problems get harder too, we'll get into a situation where we need to come up with a few new test cases, and it won't be as straightforward. But we need to get this puzzle input for the second day, or for the second problem. Save that, and let's go ahead and create solution2.rb. Require relevant ribbon 0, and total ribbon equals present line ribbon length, and puts total ribbon. All right, and solution 2.rb. Let's go back to the browser, put in 3783758 and submit. And we got the right answer for day 2. Cool. Looks like we're still, like I mentioned, we're still in the kind of training data for all of the advent of code solutions, but we still kind of haven't really written any implementation code. So I think it'll be really interesting to get to a place where we have to and see where this starts to fall down. So if it doesn't, maybe we'll come up with a couple other problems and start to TDD that. But until then, let's go move on to day 3. And yeah, let's see the problem. Santa is delivering presents to an infinite 2-dimensional grid of houses. He begins by delivering a present to the house at his starting location, and then an elf at the North Pole calls him via radio and tells him where to move next. Moves are always exactly one house to the north, south, east, or west. After each move, he delivers another present to the house at his new location. However, the elf back at the North Pole has had a little too much eggnog, and so his directions are a little off, and Santa ends up visiting some houses more than once. How many houses receive at least one present? For example, greater than sign, right arrow, delivers presents to 2 houses, 1 at the starting location, 1 to the east. Up, down, up, right, down, left, delivers presents to 4 houses in a square, including twice to the house at his starting and ending location, and then up, down, north, south, delivers a bunch of presents to some very lucky children at only 2 houses. Okay, so let's see what kind of objects we have here. So we have Santa, and then we have movement, and Santa ends up visiting some houses more than once. How many houses receive at least one present? So this is the number of houses. Okay, so we've got Santa, we've got moves, we have directions for him to move, and then we have then we want to ask how many unique houses delivered to. So let's go back to the project. Let's do a new file, and we've got santa.rb and new file santa-spec.rb. Let's go back here and change this to santa-spec day 3 and santa.rb day 3. And let's open this, move this over here, and require our spec, require relative / Santa, and let's get the agent going. Cool, tests are passing, and let's see. So we were saying we want a rspec Santa do and describe let's say unique houses delivered to and it is 2 when he moves that. It is 4 when he moves up, right, down, left. So lowercase v or uppercase v, lower. And it is 2 when, I'm gonna copy and paste. 2 when it's up, down, up, down, up, down. Okay, so let's say Santa equals Santa.new, Santa.move that, Santa.unique houses delivered expect 2 to equal 2, Santa equals Santa.new, Santa.move that, expect Santa to equal 4, and Santa equals Santa.new, Santa.move that, and expect Santa to equal 2. And tests are failing. And now we've got move directions, current position, visited houses as a set. It keeps the position. That's cool. It used a 2-dimensional array for that. Cool. Adds the current position to the set and counts the visited houses dot size. Cool. And so for how many houses receive at least one present? So I think we might be able to jump over to our solution.rb, get the puzzle input, which is that. Not there. Don't save that. Let's do a new file, input, paste that there, and then in solution.rb we will do let's say require relative /Santa. We want to Santa equals Santa.new. This is actually contents equals file.read input, and Santa.move content, or say directions, and then put Santa.unique houses delivered to. So this one seems pretty straightforward. Let's see, day 3, Ruby solution.rb, initialize constant Santa set. That's interesting. Why would that be? Why would the tests pass and the test pass in this solution.rb not initialize constant Santa set? The spec, it did work. Let's see. probably something very simple. Ruby solution.rb. Ruby Santa. I really don't want to mess with the implementation files, but I kind of want to figure out what's going on here. Initialize constant. Why would it be in that namespace? I'm going to try to change the implementation file here to figure out what's going wrong. And initialize constant set. Why is it not giving me? Do I not have the right Ruby version? Yeah, must have been some weird versioning. What Ruby did we have running before? 3.1. It's very weird. I don't know, I'm gonna write myself a note to figure out what was going on there. But we can move on. Okay, so let's see here. So we got 2572, and go to the browser, 2572, submit. That's the right answer, of course, but now on to part 2. The next year, to speed up the process, Santa creates a robot version of himself, Robo Santa, to deliver presents with him. Santa and Robo Santa start at the same location, delivering 2 presents to the same starting house, then take turns based on instructions from the elf, who is eggnoggedly reading from the same script as the previous year. This year, how many houses receive at least 1 present? For example, Up Down delivers presents to 3 houses because Santa goes north and then Robo Santa goes south. Santa and Robo Santa start at the same location, then take turns moving based on instructions from the elf, who is eggnoggedly reading from the same script as the previous year. So how should we write a test for this? So we've kind of got a new class here that Santa goes up. So in the second problem, Santa goes up and down. In the second problem, Robo Santa goes right and left. So what we want to do is so we probably don't want Santa to, we want Santa to move, and we want to know the visited houses, but we also want to break the movements up and compare the two. So we've got all the functionality to do this, but what we need to do is figure out what's the best way to write a test for this, or what's the object we're dealing with. We've got a Santa team. Let's see, we've got a Santa team, or we've got houses. We've got the house grid that we can then send Robo Santas delivering to. And really, how many houses receive at least one present? How do we break this problem down? Maybe if we give Santa, let's give Santa a unique houses delivered to. Maybe we want to change the Santa spec to return the visited houses, and then we have a delivery team that sends the movements to the Santas and then takes the set of visited houses. So let's do that. Let's change this to visited houses. Or we can leave visited houses delivered to and create a new method. Visited houses, and it is the position. Oh, I'm not showing the editor. Okay, so if we have a visited houses method, it's going to give us or basically enable us to get access to that visited houses set, but let's make sure that works. So it returns the visited houses when given the right arrow, move east, and so Santa equals Santa.new, Santa.move east, and then expect visited houses to equal that and that. Yep. Let's say it returns the correct visited houses when given up, right, down, left. Expect Santa visit houses to equal that. Up is sub 1 plus 1, so that's this one. Right adds 1 to the 0, so that's 1, 1. Let's see. So let's get rid of what Copilot's giving us here. Let's see. So we start at 0, 0, we go up, which is plus 1, so 0, 1, we go right, which is, we had some issues with the streaming here. I got some buffering. Hopefully that goes away soon. Cool. So let's see here. So we've gone starting position, we've gone up, so 0, 1. We go right, which is 1, 1. And then we go down, which is 1, 0, and then we go back, which is 0, 0, which shouldn't be in the set of visited houses. Okay, so then it returns the correct visited houses for, and let's copy and paste this one. This, and so if we do, if an individual Santa does this, then we want it to expect Santa.visit houses to equal that, right? Okay, and so those tests should pass once we add the visited houses. Actually, let's do this. And now we should be able to restart those tests. Get it to edit the, right, visit houses 2A, cool. So now we have access to visited houses. So then what we want to do is we want to create a new class, and we can create a new terminal here, and let's do delivery team.rb. Move it in here, and new file delivery team spec.rb. Move delivery team over here. We can start testing agent pair on day 3, delivery team.rb, and day 3 delivery team spec.rb. Let's get that going. No failures. Require rspec, require relative / delivery team, and are we going to need to require Santa here? I don't know, we'll find out. rspec.describe delivery team, and so let's say let's see, what methods do we want for this delivery team to do? So we want so we're going to do some dependency injection here. So we'll require relative / Santa, and what we'll do is describe let's see, so we're going to initialize a Santa, we're going to give it Santa and Robo Santa. We're going to expect that each one gets called with the correct movements. Okay, so let's say what did they call it? They call it take turns moving based on instructions. Let's say so we're going to want to initialize the delivery team with 2 Santas, and then we're going to call delivery team dot deliver presents with them, start at the same location delivering 2 presents, and take turns moving based on instructions. We want delivery team to let's say, just see what happens if we start writing method name so let's say delivery team equals delivery team.new, delivery team dot, yeah, I guess move. And let's say or we want to do Santa equals Santa.new, robo Santa equals Santa.new, Santa, robo, Santa. Actually, we can do it with named parameters for our sake. And then expect Santa to receive move with up, and then delivery team.move, and then we'll do Santa, same thing here, and do expect robo Santa to move with down, delivery team.move up down, and let's save the file and see what happens. Cool. So we got those directions, and then what we want is to also have a unique house is delivered to, and it is 3 when given up down. It is 3 when given up, right, down, left, and it is 11 when given is up, down string. Okay, so we've got Santa equals Santa.news, robo Santa equals Santa.new, delivery team. That. We're going to do that in all 3 of these. And then, let's see what else we're going to do here. Delivery team.move, and then delivery team. Unique house delivered to equal 3. And we're going to do the same here. Team.move. Right. And then delivery team.move, and expect delivery team.unique house is delivered to equal 11, and save. And so we've got a few failing tests now. We've got, looks like it's doing something else here. Tests are still failing. Okay, so maybe we found something where it's gonna have some trouble here. Okay, so we're gonna need to give it some more guidance on what to do. And this also points to a feature we probably need in the RSpec agent of being able to stop this looping when it keeps rewriting tests and it runs into something here. So I'm gonna write that down of stop stop after a few failures. And it's still going, and it's still got, let's see, it's changing threading specs and everything. Okay, so let's kill this, and maybe let's just delete everything in the delivery team file and try this again. It's also interesting that it adds the Santa class to this file. Okay, so let's kill that. And maybe dependency injection is also a bit of an issue because it doesn't know the Santa interface. Even if we're setting an expectation for it. Well, we're coming up on an hour here, and in the first half with the previous problem, it seemed like it was a little too easy, and now we've kind of run into something interesting. Couple different things potentially happening here. This design could also not be very good. It looks like I was thinking with dependency injection we could get away with not having to, or I guess just passing, I mean it's not even going to be, not having to pass in the definition of the Santa class, but it looks like that might not be the case. I'm not sure. So one, learn that passing other classes in without a defined interface might not necessarily be the right move. We have the TDD agent needs to be able to stop and kind of signal, because it looks like it gets into this loop that I've run into in the past where it just keeps churning and trying, but just keeps adding more and more. I wonder if maybe being able to try a different model as well, or maybe a different design. Maybe the tests are not correct. Is it going to be 11? One direction. Santa, Robo Santa, up, down, up, down, up, down, up, down, up, down. Right, should equal 3. Well, this seems like a good place to stop. Maybe. Let me see. Well, I guess maybe it makes sense to switch over to the agent, and let's do something like let's get it to stop at 3 attempts. So attempts equals 0, and if attempts less less than 3, do this, and 10 equals s plus 1, save that, and 0, 1, and 2, right? And then let's see, do I need to rebuild or will that just work? One, two, 3, 4. I might need to rebuild. 5, yeah, okay. Let's do puts at attempts and build testing agent.gemspec. Cool. That should work, I think. Yeah. And 3 and gem install dot slash testing agent. Testing agent 0.0.1.gem. Cool. And let's try it again. Looks like I need to get my process down for updating the testing agent done as well. But we're coming up right on an hour, and that seems like a good spot to stop and pick this up next time. But let's see here. Let's kill this. And got 10, got 11. And looks like we might need a couple more, maybe a couple more examples could fix this as well. But with it going into like adding a Santa implementation to this file, that might not be, it might not be able to figure it out. But if you made it this far, thanks for watching. It's a fun exploration of pairing in a TDD way with AI. If you'd like to join me one time in the future, we are definitely interested in doing some remote trio programming with an AI doing TDD. So let me know. Might have some guests on here pretty soon. And yeah, let us know what you think. Let us know if you get a chance to play with the TDD agent as well.